Hello everyone. In this video we are going to see the next part of 8259, that is programmable interrupt controller. We are going to see the interfacing and handling multiple interrupts using 8085 microprocessor. So let us start this video. First of all, we will see about 8259 IC. So here the 8259 is used to expand the interrupts of 8085. As we know that the 8085 processor has 5 hardware interrupts. Those are trap, RST 7.5, 6.5, 5.5 and INTR. So here we are going to interface 8259 to generate the interrupt to 8085 on INTR line. One 8259 can accept 8 interrupt requests and allow one by one to process INTR pin. Then it can be used in cascade mode using cache 2 to cache 0 lines to expand the interrupts up to 64. So here 3-bit makes 8 combinations, so 2 raised to 3 is equal to 8. So one 8259 has 8 interrupt pins, so 8 interrupt pins multiplied by 8 ICs is equal to 64 IO lines, which can be used for interrupt. Next thing is features of 8259. So it is programmed to work with 8085 and 8086 as well. Then it manages 8 interrupts according to the instructions written into its control register. So 8259, each single 8259 IC can handle at the max 8 interrupts. The priorities of interrupts are programmable. So here we are, as we have seen in the previous video, that 8259 has interrupt mask register, interrupt service register, interrupt priority register and interrupt request register. So out of those 4 registers, interrupt priority registers is used to decide the priorities. Okay, then 8259 can be programmed to accept either level triggered or edge triggered. So here all the interrupt pins can be configured as level triggered or edge triggered. We cannot mix, okay, that is level triggered and edge triggered interrupts. We have to configure either all level triggered or all edge triggered. Then the interrupts can be masked or unmasked individually. So here we can enable or disable the individual interrupts. Okay, masking means disable and unmasking means enable. Then the 8259s can be cascaded to accept a maximum of 64 interrupts. So we have seen it is possible using cascade lines. Next thing is interfacing 8259 with 8085 microprocessor. So this is the interfacing diagram of 8259 with 8085 microprocessor. So here we can interface it using IO mapped IO mode. So here this interfacing diagram is done using IO mapped IO mode, because here we are using A4, A5, A6 lines to select this 8259 chip. Okay, so here we are using Y0 line to select this 8259. That means whenever 000 bit pattern arrives on CBA lines of decoder, that time the Y0 line will go low and all other lines will become high. Then this A7 line is given to G2A bar and G2B bar, these two lines. Okay, so here G2A bar and G2B bar lines are active low lines. So A7 line should also be made low to enable the decoder, and G1 line is active high line. So this must be 1 to enable this decoder. So here IO/M bar pin is directly connected to G1. That means it is IO mapped IO. Okay. Next pins are INTR is connected to INT pin of 8259. So whenever any of these 8 interrupts will be activated, that time the INT pin will go high and it is connected to INTR pin, so that 8085 will come to know that one of these interrupt has been activated, and in response to this interrupt the 8085 will provide the acknowledgement signal to 8259, so that 8259 will come to know that 8085 has received the interrupt signal. Okay, then RD bar and WR bar, so these are the write bar and read bar signals. So read bar signal is directly connected to read bar of 8259 and WR bar is connected to WR bar of 8259. Okay, so this is the simple interfacing diagram. Then the next part is the data bus of 8259 is directly connected to data bus of 8085 processor. Okay, then A0 line is directly connected to A0 line of latch IC. Okay, so here we can have A0 and we can have either 0 and or 1 bit combination, so that you can combine this RD bar, write bar and A0 to select the particular operation. Okay, now let us see the next one. So here we will see again the interfacing part. Though we are continuing the interfacing part, it requires two internal address and they are A is equal to 0 or A is equal to 1. We have seen in this here A is equal to 0 or A is equal to 1. It can be either memory mapped IO or IO mapped IO in the system. So in this diagram we are connected here IO/M bar to G1 of 3/8 decoder IC. Okay, so G1 is active high pin. So whenever we send any 8-bit command, or whenever the processor executes out instruction or in instruction, that time the IO/M bar pin goes high, which enables this decoder. Okay, then the interfacing of 8259 to 8085 is shown in the figure. The low order data bus lines D0 to D7 are connected to D0 to D7 of 8259. The address line A0 of the 8085 processor is connected to A0 of 8259 to provide the internal address. Okay, next points are the 8259 require one chip select signal. Using 3/8 decoder generates the chip select signal for 8259, and we have generated this chip select bar signal using A4, A5 and A6 lines of 8085 processor. The address lines A4, A5, A6 are used as input to decoder. The control signal IO/M bar is used as logic high, which enables decoder, and address line A7 is used as logic low to enable the decoder. Then the IO addresses of 8259 are shown in the table. So here whenever we configure 4-bit mode, then here 3 bits are separately configured and lower 5 bits are separately configured. So here input to address are used as A0 to A4, and decoder, the upper 3 bits should be used to enable the decoder. Okay, so here either A0 line should be 0 or it should be 1. So the address form is 00 or 01 in hexadecimal. So these 3 bits are don't care, so read these 3 bits as 00. Okay, don't make these bits 111. Okay, next, first the 8259 should be programmed by sending initialization command word, that is ICW, and operational command word OCW. These command words will inform 8259 about the following. So from this initialization command and operational word command, the 8259 will understand the type of interrupt signal, whether it is level triggered or edge triggered. Then we can configure which processor we are going to interface to 8259, that is 8085 or 8086. Here 8085 is 8-bit processor and 8086 is 16-bit processor. Then call address and its interval, so we can configure the interval of 4 clocks or 8 clocks. Okay, then masking of interrupts, then priority of interrupts, then and the type of end of interrupts. Then the next point is, once 8259 is programmed, it is ready for accepting interrupt signal. When it receives an interrupt through any one of the interrupt lines IR0 to IR7, it checks for its priority and also checks whether it is masked or not. So here, if suppose IR0 to IR3 is enabled and IR4 to IR7 are disabled, and suppose if IR4 has been made high, then the 8259 will check whether the IR4 is enabled or disabled. So if it is disabled, then it will not take further action on IR4. Okay, and suppose if the IR0 is made high, then it will again check whether the IR0 has been enabled in the mask register or not. If it is enabled, then it will put that into the in service register. Okay, if it is having higher priority. Otherwise it will, if suppose IR0 is having lower priority and if suppose higher priority interrupt is being serviced, then it will not inform to 8085 processor to give the service to IR0 interrupt. If the previous interrupt is completed and if the current request has highest priority and unmasked, then it is serviced. Then for servicing this interrupt, the 8259 will send INT signal to INTR pin of 8085. Okay, so if suppose IR0 is activated and no interrupt is being serviced right now, then 8259 will first generate the INT signal, interrupt signal, to 8085, so that 8085 will understand that some interrupt is activated and we have to switch to one of the ISR. Okay, so 8085 doesn't know that which ISR it has to jump, so 8085 demands 8259 to get the ISR address from 8259. Okay, now in response it expects an acknowledgement INTA bar from the processor. Okay, when the processor accepts the interrupt, it sends 3 INTA signals one by one. So here INTA signals are used to get the call instruction from 8259. Okay, the 8259 will send the complete call instruction along with the ISR address. In response to first, second and third INTA signals, the 8259 will supply call opcode, then low byte of call address and then high byte of call address respectively. Once the processor receives the call opcode and its address, it saves the content of program counter, that is PC, onto stack and load the call address in PC and start executing the interrupt service routine stored in this call address. So this low byte and high byte is related to the interrupt activated. Okay, each interrupt has its own vector address, so it is the job of 8259 that which interrupt is activated and which address has to be sent to 8085 processor, because 8085 processor doesn't know which interrupt has been activated. So 8259 will inform to 8085 that which interrupt has been activated and what is the vector address of that particular interrupt. Now for servicing interrupt, the 8259 will send INT signal to INTR pin of 8085. When the processor accepts the interrupt, it sends 3 INTA pulses one by one. Now in response to that INTR signal, the 8259 will respond 3 INTA bar pulses, and each INTA bar pulse will have, first INTA bar pulse will have the opcode of call instruction, that is CDH. Okay, when the processor will generate the second INTA bar pulse, the 8259 will send the lower byte of the ISR address, and when processor will activate the third INTA bar pulse, the 8259 will send the higher order byte of call, that ISR address. Okay, so this way the 8259 will provide the ISR address. Next point, once the processor receives the opcode of call instruction and its address, it saves the contents of program counter on stack. So here the stack pointer plays the important role, which saves the return address onto the stack, then loads the call address into PC and start executing the interrupt service routine, which is stored in call address. So here whatever address is sent by 8259, so during second and third INT bar pulse, that address will be loaded into the program counter to fetch the first instruction of ISR. Okay, now